Good morning, boys and girls, and welcome back to the southern wing of the Stink Bug Works. I spent time yesterday figuring out how I'm going to do the drive system on this. As you know, originally I thought of this, and then I was going to put a motor on top of it, and that would be pretty cool. That'd be pretty cool. But it just left something to be desired. It wasn't quite right. And as you look at the bottom of this motor, the pivot's up here and the thrust point's way back there. And, I'm just not thinking this is working for me. And so I pulled out some of my old Fuller's hardware, and I was thinking of using, a strut and bracket like this and putting a rudder on top of it. And I got to looking at these photos of motors. What do these motors have in common? Why, they both have a skeg on the bottom of their drive housing here. And I said, no, wait a minute, wait. I have a strut with a skeg on it, just like this. Why can't I use this strut that has a skeg on it, just like this? I got to draw on a piece of paper. I don't know if you can see this, but I think I have a plan. I can mount the strut right here. Can you see that? I don't know. We'll find out. And make a carbon fiber sandwich bracket. So there would be 2 sheets of carbon fiber sandwiched on a sheet of carbon fiber that is the same thickness as this strut tang. So I'd have a sheet and a sheet and a spacer, and I'd allow room here at the end where I could drill a couple of holes for screws and have room for this to move up and down. Now, this thing's going to pivot, and I think I could make a bracket out of, a piece like this. And here's what I'm thinking. Now, when I was working on the Miss Bud, I had to do that crazy shaft extension. And I was looking at, doing something with multiple bearings, extending that shaft, and I didn't like 1/8. But in knocking around, I found some really cheap, like $8 each, really cheap ceramic ball bearings. This one has not been run yet. It's clean. These, you can see they've been inside of this aluminum tube that I was using to test on the Miss Bud. And you can see they stirred up a little aluminum dust. Well, I'm not going to worry about aluminum dust. I'm thinking of using these solid ceramic bearings in this bracket here. Why? Because they'll never, ever rust. And quite frankly, for the little amount of work they're doing, I'd probably never have to lubricate them. I opted not to use these on the Miss Bud because, quite frankly, they weren't precise enough. The shaft would vibrate if it wasn't perfect. So I went with some higher quality bearings. And these are cheap Chinese ceramic bearings, but They're more than adequate for swiveling this. Now, here's the plan on this. I'll run the larger stuffing tube with a Teflon liner, and the way the geometry of this works out because of where this edge is, it goes right about to there. So this liner can only go in this tube a couple of thousandths before it hits this shaft. I'm going to pull it back a little bit to leave a gap, and I'll put a thrust washer in there so this can go in a little further. What I'll do is I'll put shrink tube from the end of the stuffing tube to the end of the bullet. And then I'll put another piece of shrink tube over the whole thing. And then this does not need to move very much. Remember, I did this on that little wooden tunnel hull I did, kind of as an experiment for this. But the small amount of deflections I need, I can take up with the stuffing tube and this shaft. So that's what I'm thinking I'm going to do. Now, okay, so here I've got my strut. It's locked into here via a carbon fiber arm that's pivoting on this with some ceramic ball bearings. Now I need to have a motor. And here's the constraints I have. I need to be able to get at these screws for adjusting the strut height relatively easily. So they'll either have to be holes in here, or this will have to be real easy to get off. And what I'm thinking is this carbon fiber member, I can maybe put a pin or a latch or something in here where I can make this whole unit and it'll drop down on this and snap into place, or a couple of pins hold it into place, or even a screw holds it into place so that it'll come on and off real easily. Here's another thing with this setup too, and it just dawned on me. I could make a cavitation plate with a water pickup that would go right on the bottom of this carbon fiber bracket, and structurally, it would make that thing rock solid. Just rock solid. So there's my thinking and planning for the drive of this thing. I may opt to make this bracket out of something a little heavier, because with this, since these bearings are not flanged, I'd have to have some way of keeping the bearings in here. And frankly, I was thinking of just using JB Weld and just permanently attaching those ceramic bearings to this and let them become part of the arrangement. That's why I went with the ceramic, because you're never going to have to replace it. It's not going to rust. It can just stay there forever. So, or I could machine this out of a bigger hunk of metal, and then for the bearings, I could, have a 1/4 inch that steps down to a smaller, and so the bearings would be captured that way, and then I can put something on the outside to keep them from escaping. I haven't got to that part yet. Right now I'm inventing things. Soon I'll start making stuff. Right now I'm inventing things, and that's what I'm thinking. I'm thinking of having this thing just like a freaking outboard motor doing what an outboard motor does. There you go. Okay, one last thing is I gotta pimp the 120 scale. I've got wood that's going over into the pile and starting to be cut. It'll be a week to 10 days before I get the wood cut. I'm going to do 10, count them, 10 Atlas kits and 6 short circuit kits. So let me know what you want. And it's first come, first serve. I'll take Zelle or PayPal. I still got to work up the pricing on the wood. God, wood is expensive. Everything's expensive. Geez, air is expensive. So they'll probably shipping costs me like $15 to $20. The package has to be 2 feet long, and they charge extra for that. Oh, it's 2 feet long. That's going to cost you extra, boy. So shipping's a hit. These things will probably go out the door for $65. Yeah, that's not cheap for plywood, but these things are really precise. They're perfect. There's a lot of work in everything else. I give you plans for everything else. They're easy to build. They drive real well unless you put too much power in them, and then they just become these water rockets that fly off the water all the time. With a modest power system, 150 watts or so, they run really good. You put 500 watts in them, and you're going to have you're going to be using your rescue boat a lot, or you're going to be breaking stuff. Although these things, they are pretty darn solid once they're put together. On the deck skins and the hull skins and so forth, I just use 16th balsa. If you're going to be racing these things side to side and slamming into each other, I'd recommend just a single lamination of 3/4 ounce glass cloth. That's more than enough. If you want to go crazy, take 64th balsa and laminate it to 16th. Take 1/64th ply and laminate it to 1/16th balsa. So the outer surfaces could be plywood. That adds some weight, but when you're bumping gunnels, a little bit of weight won't hurt you. That's the nice thing about building your own. You can build it any way you want it. You can build it super light, just as a fun runner. You can build it rugged for deck-to-deck racing. Anyway, boys and girls, until next time, jet out.